Right, I'm going to talk about significant figures. Significant figures. And I'll give you a nice example. I once, when I was at school, I measured how far round our playing field was. And my answer was 1 kilometre, 402 metres, it wasn't this exactly, 53 centimetres, and 1.54 millimetres. Well, yeah, alright, let me write that out in kilometres. That's 1.40253. Oh, it isn't, it's 54, isn't it? Because that's 53 centimetres. Oh, that's millimetres. 53154. So what have we got here? That's my kilometre. That's my metres. Those are centimetres. And that's millimetres. Absurdly precise answer. What I really meant was it's about 1.4 kilometres. So 1.4 kilometres. So what I should have said, I didn't know any better back then, but I know now, is I should have said it's 1.4 kilometres to two significant figures. And the two is that one there and this one here. So you've got a first digit and a second. 1.4 to two significant figures. If you want to put it in scientific notation, you'd say it's 1.4 times 10 to the 3 metres. I guess you should use metres if you can for lengths in science and engineering. Let me express that to three significant figures. Sig figs. Well, that's 1.40 times 10 to the 3 metres. And to 4 sig figs, it will be 1.40, what was it? 402. Oh, actually, I should round it up to 403, I guess, because that's above the halfway mark. 1.403 times 10 to the 3 metres. And that's 4 significant figures. So what's happening here is that we're adding, as we're going down from here, down to here, down to here, we're adding significant figures. We're adding precision. Okay, and of course I could give the whole value. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. But thinking about it, it's not very likely that I'm going to measure it to the nearest tenth of a millimetre with my rolling wheel thing that I measured it with. So I'll probably be best off reporting it to probably 2 significant figures. 3 is probably pushing it. Okay, well there's significant figures. It works for small numbers as well. If I've got a small number, 0.002738592, let's say, then part of the problem with a number like this is that your eye gives as much weight to the numbers here as these numbers here. And of course these numbers are very, very much more important because they've got a higher place value than these guys here. But your eye gives them equal weight, and so it's a bit confusing. So you might say to 3 sig figs, that equals 0.0027, oh, not 273, it would be 274. Or if I wanted to write it in scientific notation, as per the scientific notation screencast, that would be 2.74 times 10 to the power what? 1, 2, 3, minus 3. Minus 3 because we're going backwards, because we're expressing a small number. Okay, they're significant figures.